For this specific wave, the Caribbean SSTs mean that if it achieves tropical depression or tropical storm organization, it will be doing so over water that can sustain and intensify a storm more efficiently than the historical averages for this time of year would suggest. The shear environment matters most for whether the initial organization happens. The SSTs determine the ceiling of what organization is possible once it begins. Sea surface temperatures in the main development region off Africa remain warmer than normal, particularly across what forecasters call Hurricane Alley between Africa and Central America. These above-average temperatures stretch from the tropical Atlantic westward toward the Caribbean and Central America, creating an environment where tropical systems, if they form, would have access to fuel. Hurricane Alley, the broad corridor of warm tropical Atlantic water between the African coast and the Caribbean, where the majority of the Atlantic's intense hurricanes develop each season. This wave has been traversing that corridor for the past week, drawing moisture and energy from the warm water surface as it tracked westward. By the time it entered the Caribbean, it was already carrying the enhanced moisture content that extended warm SST exposure provides: more water, vapor in the lower and mid-levels of the atmosphere, more convective energy available to any circulation that develops within the wave's moisture envelope. Now the wind shear, because this is the variable that separates this wave from the dozen or more tropical waves that have already crossed the Atlantic in 2026 and failed to develop. El Niño will dominate the tropical circulation during the peak of the 2026 Atlantic hurricane season, driving well above normal levels of vertical wind shear across the tropical Atlantic and Caribbean. Well above normal shear across the tropical Atlantic and Caribbean is the seasonal forecast baseline, and across most of the basin, that forecast has verified. The main development region, the zone from the African coast to about 60 degrees west longitude, has been running shear values throughout July that the NHC's tropical weather outlooks have consistently cited as hostile or limiting for development. The Gulf of Mexico has seen episodic shear reductions, the same windows that allowed Bertha to briefly threaten the Gulf Coast earlier this month, but those windows have been temporary. The deep tropics have been largely locked shut. The southern Caribbean is different for a specific dynamical reason. The El Niño's shear enhancement in the Atlantic is not geographically uniform. It is strongest in the deep tropics, particularly in the main development region and across the western Atlantic from Florida to the Lesser Antilles. In the southern Caribbean, particularly south of approximately 15 degrees north latitude, the El Niño shear signature weakens. The upper-level westerly flow that tears apart developing circulations over the main development region has less influence at the latitudes and longitudes of the southern Caribbean, particularly during periods when the subtropical ridging pattern is oriented in a way that pulls the upper-level flow slightly northward. That is the configuration that has set up this week. And the wave tracking through this geography has found itself in a basin that, at its specific location, is running more like a typical warm Atlantic year than a suppressed El Niño year. The wave will bring rain, thunderstorms, and gusty winds to some of the leeward islands this week. Rough seas are expected as the wave advances across the Caribbean. People across the Caribbean should closely monitor forecast updates as the situation could escalate quickly. Rough seas are not a secondary concern for the Caribbean island communities in the waves path. The leeward islands, Antigua and Barbuda, Montserrat, St. Kitts and Nevis, Anguilla, the British and U.S. Virgin Islands, are small island systems where the surrounding ocean directly affects daily life, maritime commerce, fishing fleets, inter-island transportation, and coastal infrastructure. A tropical wave strong enough to generate significant seas and gusty winds at the surface, even before it organizes into a named storm, creates hazardous conditions for all of those activities. The wave's convective core is currently producing conditions that local meteorological services across the Lesser Antilles are monitoring and warning about independently of the larger storm development question. Now the track scenarios, because this is where the question gets complicated and where honest uncertainty needs to be stated precisely rather than collapsed into a single forecast line. Multiple scenarios remain in play as the tropical wave begins strengthening. AccuWeather's De Silva described 3 broad scenarios consistent with the current model guidance. The first is a Caribbean scenario. The wave organizes into a tropical storm or depression over the central or western Caribbean, tracks generally west-northwestward, and affects one or more Caribbean island nations or the Central American coast before potentially entering the Gulf of Mexico. This scenario is support-ed by model solutions that show a persistent mid-level ridge over the subtropical Atlantic, maintaining a westerly steering flow through the Caribbean basin for the next several days. Under this scenario, Cuba, Jamaica, the Cayman Islands, and potentially the Yucatan Peninsula would be in the system's path as it continues westward, with Gulf entry possible in the second week of August. The second scenario is a Gulf scenario, the system develops more quickly in the southern Caribbean and takes a more northwesterly track, potentially entering the Gulf of Mexico before tracking into its western or northern coast. The Gulf of Mexico's water temperatures in late July and August typically provide the most intense development environment in the entire Atlantic basin: shallow, warm water, limited mixing depth. And a system entering the Gulf in a disorganized state can rapidly intensify as it approaches the coast. The Gulf scenario's specific landfall point and intensity would depend on the system's organizational state at Gulf entry, the steering pattern at that time, and the specific upper-level flow configuration that would either allow rapid intensification or maintain shear over the system. The third scenario is a recurving or east coast scenario. The system tracks northwestward through the Caribbean and then, encountering the westward extension of the Bermuda High on its northern flank, curves northward and eventually northeastward, potentially affecting the southeastern United States or tracking up the east coast. This scenario is less probable under the current model consensus, which shows the ridge remaining strong enough to push systems westward through most of the Caribbean transit. But it is not zero probability. Systems that organize quickly in the southern Caribbean, before they have been pushed far enough west by the steering flow to be committed to a Gulf track, have more options in terms of recurvature. The same stalled frontal boundary that has been producing flash flooding from Texas to New Jersey for the past 2 weeks creates a moisture corridor over the southeastern United States that a northward-moving Caribbean system could interact with. That frontal boundary connection is worth dwelling on because it is the element that directly links the tropical story to the weather pattern this channel has been covering throughout July. The upper-level ridge that is steering this tropical wave westward across the Caribbean is the same western heat dome ridge whose eastern flank has been acting as the conveyor belt for the severe weather. Sequence: the tornadoes in Kentucky and Ohio, the flooding in West Virginia, the flash flood emergencies accumulating at a record pace across the eastern United States. The ridge is the engine. Its influence extends from the Canadian border on the north, where it has been driving the heat records in Montana and the Dakotas, to the Caribbean on the south, where it is steering tropical systems on their westward track. When that ridge eventually breaks down, as it must as all atmospheric ridges eventually do, the steering pattern that has been pushing tropical systems westward will shift. A weakening ridge means less westward pressure on the system's track, more opportunity for northward or northeastward motion, and potentially a scenario where a Gulf-bound tropical storm instead recurves toward the southeastern United States or the Carolina coast. The timing of the ridge breakdown relative to the tropical system's position is the single most critical forecasting uncertainty for the next 10 days. Now, the El Niño context for what this wave's development would mean for the remainder of the 2026 season, because the development of any Caribbean tropical wave into a named storm in a season projected at 40 to 45% of normal cyclone energy does not necessarily signal a reversal of that projection. One storm does not change a seasonal forecast. In August, tropical cyclone generation in the subtropics off the southeast U.S. coast represents one development risk even in a below-normal El Niño season, as subtropical ridge position and local shear patterns can create windows of opportunity that the seasonal suppression does not eliminate. Windows of opportunity. That is the precise language for what this Caribbean wave has found. A window in the El Niño suppression pattern, geographic, temporary, real, that has allowed a wave with the right structural characteristics to move into a development environment more favorable than the seasonal baseline would suggest. These windows are not anomalous. They are a normal feature of every below-normal hurricane season. The 1983 season, during one of the strongest El Niño events on record, still produced Hurricane Alicia, a Category 3 storm that struck the Texas coast near Galveston and killed 21 people. The 2015 season, another very strong El Niño year, produced Hurricane Joaquin, a Category 4 storm that devastated the Bahamas. Below, normal seasons are not no-storm seasons. It only takes one storm. The 2026 season messaging from hurricane preparedness advocates has consistently emphasized. NOAA's 55% probability of a below-average season in 2026 means a 45% probability that the season verifies at average or above. And even the below-average scenario allows for storms of significant intensity if the environmental conditions line up. This Caribbean wave is the current test of that principle. It has found the one geographic window where the El Niño suppression is running at its weakest. It is moving over SSTs that are 2 to 3 degrees above historical averages. It has De Silva's high-risk development assessment. And it is doing all of this in the period immediately before the Atlantic hurricane season's peak. Statistically, September 10th is the average date of peak hurricane season activity, the date around which the most hurricanes and the most intense hurricanes tend to cluster over the historical record. The NHC's tropical weather outlook as of Sunday morning showed the wave's development probability at low to medium levels for the 7-day period. That assessment reflects the current uncertainty. Some model guidance showing development over the southern Caribbean, other guidance showing the shear environment remaining marginal and the overall El Niño background continuing to provide less than optimal conditions for organization. The AccuWeather high-risk assessment and the NHC's lower end probability do not necessarily contradict each other. They reflect different thresholds and different weighting of the same underlying model guidance. NHC's outlooks tend toward conservative estimates that reflect the average of the model guidance. AccuWeather's expert assessment can reflect the specific synoptic details that a senior hurricane expert identifies as differentiating this wave from the ones that failed to develop this season. What to watch in the next 24 to 72 hours is specific and trackable. The NHC Tropical Weather Outlook updates every 6 hours at 8 a.m., 2 p.m., 8 p.m., and 2 a.m. Eastern. Each update will either increase or decrease the formal development probability for this wave based on the latest model runs and satellite imagery showing the wave's convective organization and any surface circulation that is developing. If the NHC designates the wave as an area of interest, a formal tracking designation that appears in the outlook, the probability has crossed the threshold where the agency considers formal tracking appropriate. If that designation escalates to an invest, a numbered area of investigation, the monitoring infrastructure intensifies and reconnaissance aircraft from the Air Force Reserve's 53rd Weather Reconnaissance Squadron and NOAA's Aircraft Operations Center become available for tasking. The reconnaissance flights, the Hurricane Hunter aircraft that fly directly into developing tropical systems to measure their wind speed, pressure, and circulation, are the definitive e-tool for determining whether a surface circulation has developed and whether it meets the technical criteria for tropical depression or tropical storm designation. Before reconnaissance, the assessment is based on satellite imagery and model output. After reconnaissance, it is based on direct measurement inside the system. The difference between showing signs of development and tropical storm Cristobal is precisely one reconnaissance mission's worth of in situ measurement. People in the Caribbean, in the Leeward Islands, the Virgin Islands, Puerto Rico, the Dominican Republic, Haiti, Jamaica, Cuba, are already experiencing the impacts of this wave's passage regardless of whether it officially develops into a named storm. The enhanced rainfall, gusty winds, and rough seas that accompany a strong tropical wave are meteorologically significant without requiring a name to be dangerous. Flash flooding in mountainous Caribbean terrain from heavy tropical wave rainfall has killed people in storms that never reached tropical depression status. Maritime hazards from wave heights are equally real for a wave and for a named storm, the formal development. Designation matters for the forecasting and warning infrastructure. The rain and wind are there either way. The track scenarios that De Silva described, Caribbean landfall, Gulf entry, East Coast recurvature, will begin to resolve in the next 48 to 72 hours as the wave's organizational state becomes clearer and as the steering flow pattern evolves. The next NHC update after this video is published will reflect the most current satellite imagery of this specific system. The update after that will reflect whatever change has occurred in the 6 hours between them. In a season defined by El Niño's suppression, this tropical wave has found the window. What it does with that window, whether it organizes quickly and becomes the season's first Caribbean threat, whether it enters the Gulf with momentum, whether it recurves toward the U.S. southeast, or whether the shear environment closes the window before full organization can occur, is the question that this week will answer. And every Caribbean island community in its current path, every Gulf Coast community that has been monitoring this season with one eye on the tropics, and every East Coast community that has already spent July managing flash flooding and severe weather is watching the same forecast loop, waiting for the same 6-hour update. Subscribe right now and turn on the notification bell. The NHC Tropical Weather Outlook updates every 6 hours. Reconnaissance aircraft can be tasked the moment the system reaches invest status. And if this wave becomes Cristobal, the first named Caribbean storm of 2026's El Niño suppressed season, this channel will cover every update from Genesis through landfall before it reaches anywhere else.